Hello everyone, welcome to Learn DAX channel. My name is Siddesh and in this video we are continuing with the scenario based question series, and today is the second part of that uh, video series. So for the purpose of this demonstration, I am considering these five cases that we are going to try and solve, and this is essentially a step up from the previous video that I had done, which had simple things like average of the total sold quantity or finding the total sales amount or calculating the total profit, etc. So in this case, we are going to use different functions like top n, rank x, and we are also going to use the summarize function, which we used even in the first video of this particular series. So without further ado, let's start with the video. And let's get on with the first case, which is calculate the total sales for each product category and subcategory. So like always, I have the products and sales data, the link of which you'll find in the description so you can practice along as you watch this video. So let's get on with the question, which is to calculate the total sales for each product category and subcategory. So in order to do that, let's understand the basic logic behind it. Let's say Virat Kohli has played 10 matches, MS Dhoni has played 8 matches, and Rohit Sharma has played 15 matches. And for each match, they have scored a certain number of runs. And now I want to aggregate those runs, and I just want, okay, Virat Kohli 600 runs, MS Dhoni 500 runs, Rohit Sharma again 600 runs. If I want to see such a stat, what I'm gonna have to do is summarize these scores. What do I mean by summarize? Aggregate these scores for that particular group, which is give me the runs scored by Virat Kohli, aggregate those runs, and then give me a single row, runs scored and the player name. This is what you're essentially trying to do in when we say category wise or subcategory wise sales. So how do we achieve that? Well, let's start with something like a summarize function. But here's the thing. If I use a measure to create a summarize function, it's going to throw me an error because the summarize function is going to give me a calculated table, whereas a measure gives me a scalar value, a single value. So for this purpose, we are going to create a new table and I will call it some category underscore subcategory sales. So how do I achieve that? The first thing is we have to start the expression with a summarize function. The first argument is the table. Now the product category and subcategory columns reside in the products table, which is why I'm going to use product as the first argument. The second argument is the group by column. Now we can add 1, 2, 3 as many columns as we want, which we want to group by. In this case, we have product category and product subcategory as the columns that we want to group by. So I'm going to mention these two columns quickly. Product category, product subcategory. Now the next is I want to give a name for that particular column that I'm going to newly create. Like for example, in case of the players Virat Kohli, Dhoni, and Rohit Sharma, the new column that was going to be created was the total runs scored. So similarly, the total new column that I'm going to create here is going to be sales amount. Now the next argument is how do I create that sales amount? So I will use the sumx function and I will use the related table function around the sales table. Then I will multiply the price by the quantity and I'll just hit enter. So a new table has been created, category underscore subcategory. And I'll quickly show you how we can verify if what we have done is correct or not. But before that, let me pull these values real quick. Product category, product subcategory. And besides that, let me pull the sales amount. So this is what we have gotten by using the summarize formula and with the logic that should work. Now, if I do one thing, which is we already have the product table, and if I pull the category and the subcategory and the sales amount from the sales table, and to verify if what you have done is correct, I'll just keep those tables side by side and verify, okay, if it is correct. So the first row, accessories and eyewear, 1460 is the sales amount, okay. So we can verify the first row. The second row has appliances and kitchen appliances in both the tables with 6400 being the sales amount. So if I go row by row, I can see that the numbers are adding up. There's no distinction between these two tables. So we can verify the first problem that we have solved is correct. So it's simply a summarize statement, summarize function that we have used, and we have given two column names as the argument, product category, product subcategory, and then in order for evaluating the aggregation, we have used the sumx function in which we have used the price into quantity, and then we get the output. So the first question is done, fairly simple. Now what we want to do is we want to determine the average sales for each product category. So how do we calculate average sales? So the basic math behind average is take the total and take the number of occurrences. So we already have the total, which is 24,313. Now, if I want it average for each product category, it means I need the count of individual product categories in this case, which is we have electronics, we have clothing, we have appliances, we have books, we have furniture, and we have accessories. So we have in all six unique product categories. So what we are really looking for is if I do this manually, what we are essentially aiming for is 24,313 divided by 6 is what we should get as the output if we are using the Averagex function. So let's see how do we achieve that. Before I start with the average, what are we going to need at the basic? We are going to need the total sales amount. So I'll create a measure, average sumx sales, sales quantity or sales price rather into sales quantity. So this is step one. Step one is to get the total sales. The next step is to define average X, and within average X, I have to define the product category and this particular expression, which is going to calculate me the total sales amount. So what I'll do is I'll create an average X function, and in the table I'll write product. And because I am iterating, or for that matter, my first argument is a product table, whereas the calculation or the aggregation is being done on a sales table. So I'll just use the related table function. And then I'll just see like what output do I get. So the output that we are expecting here is 4052.16. So if I quickly pull it here, convert it into a card, 2431. Okay, this is unexpected. This is not what we should be getting. Then what exactly 2431 is and how do I get to 4052? Well, what has happened here is our first argument, which is the table, the product table is now going to count the number of occurrences in the product table. So because there are 10 product IDs, it is going to essentially divide 24313 by 10 and then give me this number. Now, if you think that, okay, but why is it giving me 2431? It should give me 2431.3. It's just because of the formatting. If I go here, change the display units to none and change the decimal to one digit, then I get 24,2431.3. Now, in order to get to the correct answer, what I have to do is instead of directly using the product table, what I'll use is another table function is the values, in which I can pass as an argument the product category column, which is the specific column with respect to which I want to calculate the average for the total sales. So once I hit enter, this measure is going to give me the correct output, which is 4052.2, and this is what was expected from this particular question. So we are done with 2, we're left with 3, let's go with the third one. We have to identify the top n subcategories based on total sales. Now for this purpose, I'm going to use a top n function, and it's a fairly simple function, and maybe I'll make a video sometime in the future, but for the purpose of this demonstration, we'll just stick to this top n function being very simple, and we'll just add the data as the arguments that it shows up when we are populating the arguments. So note one thing, because top n is going to give us a series of rows or columns, it's going to give us essentially the top 3 values, top 5 values, or top 10 values. It's not going to be a scalar single value, which is why we don't use a measure, but we use a table. So I go to modeling, I create a new table, and let's say I want top 3. What did we want? We wanted subcategories. Okay, top 3 subcategories is equal to top n. The n value is 3. The table is product. The order by expression is my expression, which is the sales amount. So I'll write sum x. Again, related table, not just table. Sales, sales price into sales quantity. And the order is going to be descending. But there is a catch here. If you have noticed one thing, and that is here I have not mentioned the product subcategory, and that's going to give me an incorrect answer. So if I mention the product subcategory in a values function, then it's going to give me the correct answer. But let's just see what happens if I just use product instead of product category. So I'll still get the output, but let's see what output do we get. So the reason it has given me all the columns, see, it has given me product category, product color, product ID, product name, product subcategory, because here we have defined the complete table. But the moment I change it to values, product subcategory, and then hit enter, this table shortens to only showing me the product subcategory. So now I pull this quickly here, and it is giving me, okay, these are the top 3 product subcategories. Let me just change the formatting. And like I've been doing in multiple instances to verify if my answer is correct or not, I will just quickly grab the product subcategory from the product table. I will change the formatting, and correspondingly I'll take the sales amount from the sales table, pull it here, and then I'll just sort it descending by the sales amount, and then I get computer, kitchen appliances, and phones as the top 3 subcategories. And if I go to this table, computers, kitchen appliances, and phones. So far we have solved for all the 3 cases and it's correct. Now let's move on to the next 2 cases. So the first case is calculate the contribution percentage of each category to the total sales. So what this question essentially is asking us is that for every category there has been a sales that had happened. For example, let me just pull the product category here, and so we have these product categories, and corresponding to them there has been a sales amount that has happened, and we have the total sales as 24,313. So what this question is asking us, I want the contribution percentage of each category, which means if I consider the accessories, then accessories has a contribution of 1460 divided by 24313, and similarly appliances has a contribution of 6400 divided by 24313. So this is what I want to get using some DAX function. So how do I achieve that? So the first step is I need to create a measure which is going to give me the sales amount category wise. Now this sales amount comes from a calculated column. We are not going to use that. We are going to create something from scratch. So I'll write sales amount category wise is equal to calculate sum x sales amount, sales table, sales price into sales quantity, and then I hit enter. I will remove this column and instead I'll pull this measure over here, which is going to essentially give me the same output. Now what I want to do is I want to negate this filter context that exists, and instead I want the whole column to give me the one single value, which is 24313, which is the sales amount overall, which does not respect the context of the product category. And in order to achieve that, all I'm going to do is use an all function, which is going to negate that filter context. So sales amount overall is equal to calculate the same formula so far, sales, sales quantity into sales price, and then I will wrap this in the all function, So once I do that, instead of getting me the sales amount for each category, I'm going to get a sales amount overall for the product table, which is going to be 24,313. Now, in order to calculate the contribution percentage of each product category, I will simply divide these two measures. So I'll write sales, or I'll write category wise contribution is equal to divide sales amount category wise with sales amount overall. And in case the denominator is 0, I'm just going to say, hey, okay, if the denominator is 0, just give me a 0 value. In this case, the denominator is not going to be 0, but this is just one way of negating the effect of a denominator being 0. So I hit enter and I bring this measure onto this table. I will change the setting of this measure to percentage, and then this is what we get. So the contribution of appliances as per our calculation is supposed to be how much? 6,400 divided by 24313, which turns out to be in 200, 26.32%, and that's what we are getting here. Let's tally it for one more use case. Let's try to find it for the electronics product category. So I'll divide 15,390 divided by 24,313 into 100, which gives me 63.29%, which is exactly what we are getting here. So done with 4 cases. And now we come to the last part of this video, in which we are left with this last question where we have to rank product categories based on total sales. So this is going to be a fairly straightforward function. So I create a new measure. I call it ranking by category is equal to. So I will explain how this function is built as we move along. So the function name is rankx. The first argument is obviously a table. So I'll use the product table. The expression is going to be the sales amount. So how do we calculate the sales amount? I use the sumx function. I use the related table sales, just like we have been doing in this demonstration multiple times. Sales price into sales quantity, and then once I wrap this thing, I'll choose the order as descending. I'll close the bracket, and then I pull the product category from the product table, and I pull the rank from this particular measure. I'll change the formatting so it looks better, and I have some problem. How can each product category have the rank 1 when clearly accessories has a sale amount of 1460, appliances has a sales amount of 6,400, electronics has a sales amount of 15,390? There's definitely some problem. The problem is the presence of a filter context. And in order to negate the filter context, what do? Is we use the all function. So that's what we're going to do, and not just use the all function, but we are also going to be very specific about the table by mentioning the product category. And once I do that, it's going to give me the magic. Let me just sort it in the ascending order. So electronics is at first rank, it has scored 50,390. Second is appliances, which has sold 6,400. The third is accessories, which has sold around 1460. So yeah, our calculation is correct. We have arrived at the solution. So this brings us to the end of this demonstration. I hope you found some value from this video. And if you have some feedback, please share it in the comments, and I'll definitely work on myself and try to improve my future videos. And if you like this video, please share it with your friends. And like I say at the end of every video, thanks for watching and happy learning. And also before the end, I just wanted to mention that I'm going to put the links of my previous videos in the description. So if you want to check out videos related to functions like summarize, if, switch, distinct values, you can just check those videos out as well. So thank you, and hope to see you soon in a future video.